So we're going to have a look at non-linear relationships today. This is a linear relationship. These are non-linear because the variable x is not on its own. It's to the power of something. Sometimes when you're given a graph, you don't know whether it's going to be cubic, like the green graph, or whether it's going to be quadratic, like the blue graph, because you can only see part of the graph, or you're only given part of the information. We're going to go through a few examples. In many circumstances, the variables we consider are not directly proportional. But there is direct variation. This is what we were talking about before. Direct variation is when there's a relationship between their powers. So we've got one variable, such as a, is proportional to the other variable squared. And the constant of proportionality is the number which goes in front of the r squared, and for this particular example, it's 4 pi. So this means that as r gets bigger, the surface area of a sphere also gets directly bigger because it is a direct variant. Let's have a look at this example. Suppose this relationship, y equals 2x cubed over 7. First of all, state the two variables which are directly proportional and determine the proportionality constant k. This is a really easy example. What you have to do is study these numbers and these letters and just see what are the only two letters given here. Well, it's clearly going to be y and x cubed. Therefore, for our answer, we're going to say we have proportionality between y and x cubed. Remember, you need to use this fish symbol. And then k is simply the additional constant of proportionality. What other number is used in front of our second variable? 2/7. So k is 2/7. Have a go at these three questions here. Hopefully you got the following answers. Pause the video and mark, please. So continuing on with more challenging questions, let's have a look at this. We could see that d is proportional to z squared. And it gives us 3 bits of information, 14, 5 and 15. If you've got to find what d is when z is 15, all you need to do is put these 3 values in a table. Z is 5, Z is 15, 5 and 15. Now, D is 14 here when Z is 5, and we need to work out what is the missing number here. The answer would be 126. There are a couple of ways to do this. First of all, you could do it how it's shown on the screen, but perhaps there are other ways to do this particular question. I will show you now. Let's say we're going to say that we've got a relationship between 5 and 14 such that d is proportional to z squared. So we're going to say that 14 is proportional to z squared. It hasn't included our constant k, so let's include that. K and z squared is going to be 5 times 5, which is 25. Now, if we go to the next value, we would like that d is proportional again to k times the constant squared. k times the constant squared is going to give us the following. K, lots of, now our constant this time instead of 5 is 15, so it's going to be 225. Now, because k stays the same in both of these different lines of mathematical working out, we can use what's left over to work out how to get from 14 to our missing number. The way I would do it is I'd say, how many 25s go into 225? Well, that is 9. So to get from 14 to the missing number, because we are keeping constant ratios, we do 14 times 9, which is why we get the answer of 126. That is the way I would logically think of it. If you prefer not to do it that method, you can pause the video and have a look at this method here. Welcome back. Let's have a look at this question. Now this question is different. Alexa, stop. And the reason why this question is different is because we're given the d variable but not the z variable. Now if d is directly proportional to z squared, we need to first of all work out how we get from the first term of d to the second term. We times by 10, and because we're doing the opposite of z squared, we need to square root the 10. So this is the textbook response. Now if you wanted to do it my way, let's have a go at doing that. If you're going to include the k in the equation, you don't need to do the fish symbol like I did last time. You can just write straight the equals sign and the k. So let's pick the d value. We're going to pick the relationship between the 14 and the 5 again, as we did before. We're going to say that d, which is 14, is directly proportional, so we can put the equal sign, not the fish symbol, k lots of z squared, which is 25. Now similarly, we could say that we have d, this time which is 140, is proportional to k lots of an unknown squared. So what you need to do with this is work out how you get from 140 to 14. Well, you divide by 10. So to get from 14 to 140, we times by 10. So to get from 25 to the question mark squared is going to be, I believe, 250. From 25 to question mark squared is going to be 250. So we say question mark squared equals 250. So to get the question mark, as you'd expect, we just square root this, which gives us our answer of 15.8. I'd like you to pause the video and have a go at these questions. Welcome back. Here are your answers. Now we're going to go on to inverse variation. Let's say someone is driving 200 kilometres from this location to Minsk, and they're travelling at an average speed of 50 kilometres per hour. So using the equation speed equals distance divided by time, we clearly know that the time is going to take 4 hours using the 200 and the 50. However, if they're travelling at 100 kilometres an hour, it's only going to take 2 hours. So that doubling the average speed will halve the time taken. So this is an example of an inverse proportion. As one variable gets bigger, the other one is going to get smaller. Now, let's have a look at this particular graph. Two variables are inversely proportional or vary inversely if one multiplied by a constant, the other is divided by the same constant. Let's suppose this person travels with an average speed of x. This is an unknown constant. And the trip takes y hours. The table below shows some possible combinations of x and y. Now this forms a hyperbola. Now, when we have inverse variation, these are the points that are important. As x gets closer and closer to 0, y gets really big. You have this kind of pattern here. As x gets really big, y gets really small. We call these asymptotes. An asymptote, remember, happens in exponential graphs. This line tends towards the asymptote, which is the axis, but it never actually touches. Similarly here, it tends towards its axis, but never touches. And the last but most important point about inverse variation is points are inversely proportional if when you times the coordinate pairs together, they all equal each other. 25 times 8 is 200. 40 times 5 is 200. 50 times 4 is 200. And this is a really important note. Please note this down in your books now. So, the difference is with this is we've got y is inversely proportional to x. Then we have y fish symbol 1 over x. So as y gets bigger, x gets smaller, or as x gets bigger, y gets smaller. In this instance, if we get rid of the fish symbol or the proportionality symbol, we're going to replace the 1 with the k, which is a constant. So it's exactly the same as direct variation, apart from these 3 new points and the way we represent it as a reciprocal or fraction. Please pause the video and write this down. Let's go over some questions. Suppose y is inversely proportional to x and that y equals 12 and x equals 10. Find out what happens when y equals 40. Now, this is a really easy question for inverse proportionality because we said that the coordinate pairs need to multiply to give the same thing. So all you do is you do 10 times 12, which is 120. So the missing number here must be 3. And the reason why this works is because if the x is getting bigger, and for inverse proportionality, we're going to talk about it in terms of multiplying because it's easier, we times this by 4. Now, if we times the x by 4, we need to divide the y by 4, which is why when we multiply these pairs together, they always equal the same thing. Similarly, for this here, the pairs need to multiply to the same thing. So 10 times 12 is 120. So you need to see how many 19s go into 120, and that's 6.32. So the missing number is 6.32. Alternatively, you can do the difficult working out below. Now, what I'd like you to do is have a go at some of these examples. I'd like you to pause the screen on the screen in a moment, and then later on I will give you some more questions. Here are your answers. I apologise for the quality. So you can also get powers. Now this is the most complicated thing. In the powers for the direct variation, we could use a bit of guesswork, but for this you have to be definite in what you're doing. So let's when we're talking about inverse proportion but using squares. Like before, I'm going to use the ideas given in this working out but do it my own way. So it gives us 3 bits of information and we can quite easily put those into a table. The next thing I would do is it says that P is inversely proportional to the square of n. So the proportionality P, fish symbol, 1 over n squared is true. That's what we know is true. We also know that when we remove the fish symbol, we can insert the k and the equal sign. Let's do that. So what we're going to do is we're going to substitute in our specifics into our equation. So when P is 40, we're going to have this equal to the following. K as the numerator over n squared, and n is 6. So this is going to be 36. We could also say we want to work out what this missing number is here. And I'm going to do this in a slightly different way. Because we have worked out that k can be 40 times 36. Now that's going to be a rather large number. Let me just work that out promptly. That's going to be 120 plus 24, 144 times 10, which is 1,440. I did that just by multiplying these two numbers together, the 40 and the 36. Now I've worked out the k, I can actually substitute that into this equation with this time the 12. So let's say we're going to focus on this side of the table. The first equation was generated using the 40, which is here, and the 6, because 6 times 6 is 36, and then solving for k. I'm now going to use it using the 12. The 12 is our n, so it's going to be put on the denominator. That is going to be 12 times 12 because it should be 12 squared using the n squared because it's inversely proportional to the square of n, so it's 144. Our k is going to be 1,440. Therefore, the numerator divided by the denominator is going to give us what P is. P is simply going to be 10. You can see they've done it a completely different method here. If you prefer this method, please use it. Let's have a go at question B. With question B, we're going to do a very similar thing. We're going to say that k is going to be used in this proportionality, and we're still using the same relationship. We're going to use the 40 and the 6, and using the 40 and the 6 as we did before, we're going to get that k is equal to 1,440. Then all we need to do is substitute it into our equation. This time we're going to substitute in P. So P is 90. K, which we're going to substitute in for the numerator, is 1,440. And then we need to calculate out what n squared is. N squared then can be moved to the numerator of the left hand side and the 90 can be moved to the denominator, we're going to get that n is equal to 1440 divided by 90, Alexa stop, then square rooted. N is simply going to be 4. This is getting more challenging, but all we're doing is we're using this equation on the left-hand side. We get rid of the fish symbol sign and we replace the 1, which is going to be the numerator of the fraction, which is at the top here, with k. We then substitute in p and n in one instant, 40 and 6, because this is 6 squared, and rearrange to find k. Once we're done with that, we then substitute k into our second instance. So we know that p is 90 and we want to find out what n squared is. We know k is 1440. We rearrange to solve for n. It is not that difficult when you get your head around the simple manoeuvring. I'd like you to have a go at these questions here. Now, these are your answers to the questions. Now, we have something which is a little bit more challenging called determining the variation model. Sometimes you're given a few points and you're asked to work out what kind of model is it. Is it going to be linear, AX? Is it going to be quadratic, or is it going to be cubic? Let's have a look at an example. The area A, which is on the y-axis, is directly proportional to the square of radius r. Now the first thing I would do is write down the proportionality relationship. The proportionality relationship is going to be A is proportional to r squared. That is it. Find the equation of the variation model. Now we've started this process, but we actually need to find k. And k is the constant of proportionality. So we did the first part, which was a r squares. And all we need to do to this is to substitute like we did before. So we're going to say a is equal to k x squared, or k, in this instance, x is r squared. All you do is pick a random coordinate. Now, I'm going to go for this coordinate because it goes exactly through the cross-hatchings. This is when r is 2 and a is 3. We'll replace r with 2. 2 times 2 is 4. Then we get 4k. A we've said is 3. So rearranging, all we get is that k is equal to 3/4. So all you need to do to find the equation of the variation is substitute the 3/4, which we've done from solving this equation, back into our original equation, which is a equals k r squared. Easy peasy. Now, have a go at a few of these questions. I'm going to zoom into questions 1, 2 and 3. Now I'm going to scroll down so you can pause this later. And we're going to have a look at 4 and 5. Here are your answers. Last but not least, you can use technology, and this is the most fun thing in this particular topic. So, what you're going to do is you're going to get your calculator open. On your calculator, you are going to start inputting some stats. This is our favourite thing to do. And basically, the calculator can tell us what kind of model it is. We're going to go onto the Stat menu, Edit. We're going to put in this data. Before we edit, we need to clear the list. Number 4, clear list 1 in my instance. Second 1, clear list 1. Go back to Stat, Edit, put in the numbers. Let me check. Perfect. Now we're going to go into list 2, put in the numbers. That's it. Now, normally, when we want to see what the relationship is between these 2 points, we need to change the stat plot because we've entered the information into the list format. Press second y equals, press enter. All you need to do for this section then is, as we said before, go on to plot 1 and you need to check it is on. Now, normally your calculator will be off because this works with the y equals button, but we want it to be on. And this means when we press graph, we can see the graph as we do in this picture here. So draw a scatter diagram of this data. You can either use it using the calculator or do it on your page in the exam, and it will tell you whether to be exact or not. If it's not to be exact, you can draw the general shape using the calculator. Obtain the power model. Now this is the most exciting part of the lesson. This is what you have to do. Go back onto the stat menu and go onto the calc. Normally we would go onto 2 variable statistics or we'd go onto lin reg. But for this particular example, we're going to go to Power Reg and it says obtain the power model. This basically works out for us, is this a square model to the power of 2, to the power of 3, to the power of 4? It's really exciting. You put list 1, list 2, leave frequency empty, press calculate, and then we get this. So it's saying that our model suits this equation, a x to the power of b. A is less than 1, b is very close to 3, and our R value, Pearson's, is very, very close to 1. So these are our conclusions. We have M, which is our Y, is proportional to, and they've used approximately proportional to, and that's quite important that you do that for these questions. If you don't remember, you could do an equal sign, but it's like a wave sign, so it's approximately equal to 0.0326 because that's our value of A times x. Our x is R to the power of 3. And that's it. All you have to do is go on the calculator and substitute it in. Easy peasy. Estimate the mass of a ball bearing with radius 22. So using this model, even if you got it wrong, you'd still get method marks for this. You just have to substitute in R for 22. Our answer is 347. Last but not least, it says to talk about whether this model is good. You should justify it. The correlation coefficient R is very close to 1. I am going to give you some questions on this. These will be also on the document I have shared with you. Here's questions 3 and 4. And below, here is question 5. Here are your answers.